If you add all the positive whole numbers, so 1 plus 2 plus 3, all the way up to infinity, what do you get? Well, it's just going to be infinity, right? Wrong. It's actually equal to minus a 12th. What the actual smurf? And I'm going to prove it to you in two different ways. One using basic arithmetic with infinite series, and one using something called a zeta function for those who are interested. Now let's first consider this result here. 1 minus 1 plus 1 minus 1 going on forever. Now, if I was to write this again, but just shift it to the right like this, it's the same expression, but I've just moved it on the page. Now, the trick here is to add them together. So if I add these two together, x plus x is 2x. And if I add the two expressions on the right together, 1 plus blank is 1, minus 1 plus 1 is nothing, 1 plus minus 1 is nothing, minus 1 plus 1 is nothing. So we just get 2x is equal to 1. And if we halve both sides, x is equal to half. So this result here is equal to half. Okay, the next part of the proof we need. What about 1 minus 2 plus 3 minus 4 plus 5 going on forever? Now, if we use the same trick again, so we just shift what we've written to the right, then if we add these together, you get 2y, and then 1 plus blank is just 1, minus 2 plus 1 is minus 1, 3 minus 2 is plus 1, minus 4 plus 3 is minus 1, 5 minus 4 is plus 1, etc. And we already know that 1 minus 1 plus 1 minus 1 going on forever is equal to half. And if we halve both sides, we get y is equal to a quarter. So this expression here, going on forever, is equal to a quarter. Now let's try and put those together. If we had 1 plus 2 plus 3 plus 4, etc., let's call that k. If we multiply this by 4 to get 4k, then the 1 becomes 4, the 2 would become 8, and so on. And then if we subtract these expressions this time, k minus 4k is equal to minus 3k. And then we've got 1 minus blank is just 1. We've got 2 minus 4, which is equal to minus 2. We've got 3 minus blank, which is equal to 3. 4 minus 8 is minus 4, and so on. And can you see that this expression here is what we found earlier? We know that is equal to a quarter. And if we divide both sides of the equation by minus 3, we get k is equal to minus a 12th. And therefore, 1 plus 2 plus 3 plus 4 all the way to infinity is equal to minus a 12th. QED. Now, if you're still with me, I'm going to show you a different way we could prove the sum of all the natural numbers is minus a 12th. This complicated function here is known as the zeta function. So, for example, if I wanted to do zeta of 2, that would be 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, all the way up to infinity. And this particular sum is called Basil's problem. It turns out that the sum of the reciprocals of the squares of the natural numbers, as we have here, is actually equal to pi squared over 6. And we might need to use that result later. But if we have, for example, zeta of minus 1, then it would be 1 over 1 to the power of minus 1, plus 1 over 2 to the power of minus 1, plus 1 over 3 to the power of minus 1, and so on. But if you simplify that, you just get 1 plus 2 plus 3 plus 4, etc. So whatever zeta of minus 1 is, it'll be the same as the sum of the natural numbers up to infinity. Now there's an alternative formula for the zeta function, which is this complicated expression here. And don't get too upset, I'm going to show you how we can use this formula. Now we're trying to find zeta of minus 1, we said. So that's going to be 2 to the power of minus 1 times pi to the power of minus 1, which is minus 2, times sine of pi times minus 1, so minus pi over 2, multiplied by gamma, I'll explain what that means in a second, of 1 minus minus 1, which is 2, multiplied by zeta of 1 minus minus 1, which is zeta of 2. Now let's simplify this. 2 to the power of minus 1 is equal to half. Pi to the minus 2 can be written as 1 over pi squared. Sine of minus pi over 2, that angle's in radians, if you've seen radians before. It's the same as sine of minus 90 degrees, which is minus 1. Now the gamma function is just a version of the factorial function, which also works on decimals, for example. But it's offset from the factorial function by 1. So gamma of 5, for example, would be 1 less factorial. And 4 factorial means 4 times 3 times 2 times 1. So therefore, gamma of 2 would just be 1 factorial, which is just 1. So we therefore get times by 1, and then we're timesing by zeta of 2. But we saw earlier that zeta of 2 is pi squared over 6. So I can replace this with pi squared over 6. Now, if I simplify this, I can see the pi squared over pi squared is going to cancel. And the rest of this simplifies to minus a 12th. And again, we've proven that the sum of the natural numbers up to infinity is minus a 12th. QED.